Class 11th Chapter 3 Trigonometric Functions. The word trigonometry is derived from the Greek words trigon and metron. It means measuring the sides of a triangle. The subject was originally developed to solve geometrical problems involving triangles. It was studied by sea captains for navigation, surveyor to map out the new lands by engineers and others. Currently, trigonometry is used in many areas such as the science of seismology, designing electric circuits, describing the state of an atom, predicting the heights of tides in the ocean, analyzing a musical tone, and in many other areas. Now we learn about angles. Angle is measure of rotation of a given ray above its initial point. The original ray is called initial side, and the final position of the ray about rotation is called the terminal side of the angle. The point of rotation is called the vertex. If the direction of rotation is anti-clockwise, the angle is said to be positive, and if the direction of rotation is clockwise, then the angle is negative. So this is figure 3.1. So suppose this is a ray OA, and initially it was here, this initial side. So after rotation it is reaching this place, so that is known as then it is terminal side, and it is being rotated along this point O, which is known as vertex. Now there are two kind of ways. You may have seen a clock. The needle of a clock is moving in which direction? That is known as clockwise direction, and you can see that here we are moving opposite to the direction in which the needle of a clock is moving. So that is known as anti-clockwise direction. That is known as anti-clockwise. So whenever we are moving anti-clockwise, the angle is taken positive, and we are moving in the same direction as the needle of a clock. That is known as clockwise. So this is clockwise. In that case, we say the angle is negative. So these are two ways of representing an angle. One is anti-clockwise, another one is clockwise. So in this one, now what is degree measure? Suppose we are having, say, let this be a ray. So OA is a ray, and when we take one complete rotation, so that is known as 360 degree. So one complete rotation is taken as one complete rotation, that is we have started from here and we are moving anti-clockwise, so that means against the direction in which the needle of a clock is moving. So one complete rotation is known as equal to, that is taken as 360 degree. So what will, suppose we are here and we are moving here with say equal length from here, and like this we rotate, we will get one complete circle, and that is one complete rotation. So it is equal to it is taken as 360 degree. That means we are dividing that complete rotation into how many parts? 360 part. So each part of that rotation is known as because we have divided that in 360 parts, so each part of that the 360th part of that rotation will be known as 1 degree. So that is what we will write. 1 degree is equal to 1 by 360th part, 1 by 360th part of a rotation, of a complete rotation. So now you may be knowing that straight line is of 180 degree. Why it is 180? Because we are only half rotation. Half rotation means half of 360. Half of 360, because 360 is complete rotation, so equal to 180 degree. So this is the reason for which we say that the angle subtended by the angle made by a straight line is 180 degree. Similarly, you may knowing that suppose whenever we have two lines perpendicular, then we say that the angle in this case is 90 degree. Why 90 degree? Because if you see the rotation, this only how many parts will be there. Suppose you move like this, 1 2, then this 3 and 4, there are 4 parts, and out of 4 parts we are taking only one part. So that means it is 1/4 of complete rotation, 1/4 of complete rotation, and that is equal to how much? 1 by 4 of 360 degree, and that will be equal to 90 degree. So this is how it is, 90 degree. Now when the circle is very small is okay, but when the circle is very large, in that case what will happen? even 1 degree, if you see, take very very big circles, extremely big circles, then the uh, area covered by 1 degree will be also very large. So that is to be further divided into, they have divided that further into parts, and how many parts? 60 parts. So 1 degree is divided into 60 parts, and each part is known as minute. So single will mark here, just put one dash, that is equal to 60 minutes. And as discussed earlier, if the circle is very very large, even that 1 minute will be bigger. So we'll divide that 1 minute also into 60 parts. So we'll be getting 1 minute equal to 60 seconds. So when we put double bar like this, it is known as double dash. So that is 60 seconds. So most probably we will be not writing words, we will just mark like this. So it's 60 seconds, and when single dash is there, it is 60. This is symbol for minute, and this symbol for seconds. Now here some of the angles are given. 360 degree, you can see that complete rotation, but the rotation is in this direction anti-clockwise, so it's 360 degree. 180 degree as discussed, this is half rotation, 180. This is 3/4 of the rotation, so it is 270 degree, but it is anti-clockwise. Similarly here 420 degree means, what is the meaning of 420 degree? That means equal to 360 degree plus 60 degree. It simply means the person has started from here, one complete rotation has been taken, and then 60 degree more, the person has moved anti-clockwise direction. So that is the meaning of 420 degree angle. And minus 30 degree means simply from OA the person is moving downwards, that is moving in the direction as the needle of a clock is moving. So that is known as clockwise. So here the rotation is clockwise 30 degrees. That is if we take we know what is 1 degree. So like that, if you take 30 parts but moving downwards, that is minus 30 degrees. Same way here, minus 420 degree means one complete rotation has been taken but in the direction of the needle of the clock, and 60 degree more but downwards. That is total is minus 420 degree. So these kind of figures can be asked in the exam. That is, draw the figure of say minus 420 degree, or minus 270 degree, or 180 degree, or 420 degree, or minus 60 degree, minus 45 degree. This all you have to learn. Now radian measure. There is another unit for measurement of an angle called the radian measure. What is radian measure? Angle subtended at the center by an arc of length 1 unit in a unit circle is said to have a measure of 1 radian. So suppose here we are having a unit circle. Unit circle means a circle whose radius is 1, and in that case the angle made by the arc at the center with the this two radii is there, between them the angle, that is this angle, that is known as 1 radian when the radius is equal to 1, and also the length of the arc is equal to 1. So angle subtended by an arc of length 1 uh, in a circle whose radius is 1, that is known as 1 radian. Minus 1 radian is simply we are moving downwards, we are moving clockwise. Whenever the angle is positive we are moving anti-clockwise, whenever the angle is negative we are moving uh, clockwise, and whenever the angle is positive we are moving anti-clockwise. So here also the rotation is clockwise, here the rotation is anti-clockwise, so it is positive, here it is negative, so the rotation is clockwise. So this is how we have moved. Now we can generalize also this one. So whenever here what we are having is that when we are having an angle of when the arc is of length 1 and the radius is 1, in that case the angle at the center is how much? 1 radian. But suppose the radius is of say r equal to radius, and suppose the length is length of arc is equal to say L. In that case the angle made by the length of the arc at the center will be theta equal to L by R. Why L by R? Because it must satisfy our initial concept of 1 radian. So you can see that if suppose we take in this case, you can see that L and R, L is also 1 and R is also 1, that means L and R are equal. So here also when L, and in that case we are getting the angle as 1 radian. So you can see here length of the arc is 1, radius of the circle is also 1. So in this case, what is the radian? We say 1 radian. So that should be true for all, because angle, we know that if we increase the length of the arms, suppose this is say 60-degree angle, and suppose I just enlarge the arms, so then also it will be 60-degree angle only. Suppose I increase this one, the angle is not going to change. So same concept will apply here. So this will be true only when, suppose I take L as say R. So theta equal to R by R is 1. So that means this is true. This theta we have taken as L by R. So it holds for this, because whenever here we have seen that whenever the radius is equal to the length of the arc, so that is when L equal to R. So when L equal to R, what we must get? We must get the radius as, sorry, the angle as 1. So here we can see that L by R equal to 1. L by R equal to 1. So in general we can say that, so that is equal to say that is equal to 1 radian. So that means in general we can say that theta radian equal to L by R. This is true for all. This is for 1 radian, but this is when L is equal to R, and uh, therefore we can say that theta equal to L by R. This is in general. Even when the radius of the radius of the circle is not 1, we can use this formula, because every time it is not, it may be not necessary that the radius of the circle is 1. We may not be working every time on a unit circle. So in that case, we will use the formula as theta equal to L by R, and it is true even when the radius is 1, because in that case we are getting theta as 1 by 1. So we have seen that whenever the length of the arc is 1 and radius of the circle is 1, we are getting the angle separated by the arc as 1. So this is what we are getting here. So that means whatever we have assumed, that is correct. So now let us move further. Relation between radian and real measures. Let the point A represent the real number 0. Here we are having unit circle, and suppose point A represents the real number 0, and suppose if we rope the line AP in the anti-clockwise direction along the circle and AQ in the clockwise direction, then every real number will correspond to a radian measure, and conversely. So thus radian measure and real measures can be considered as one and the same. So it simply means that when we are rotating this unit circle, so when we are moving say anti-clockwise direction, what we will get, because it is we know that the radian is nothing but is the length of the arc on the unit circle. So when we move this in the anti-clockwise direction, we will get all the positive real numbers, and when we move it in the clockwise direction, we will get all the negative real numbers. So that means we can say that the relation between radian and real measure, that the when we rotate the circle of unit radius, it will cover all the real numbers. So we can say that radian measures and real numbers can be considered as one and the same. So now let us go further in this one. We have seen that suppose this is circle. So this circle, suppose this is our point O, this is A. So when we take the complete rotation, what we are getting, that is equal to 360 degree. So one complete rotation is equal to how much? 360 degree. And suppose this is this suppose is circle of radius 1. So one complete rotation, in that case the length of the arc will be how much? 2 pi, and we know that when the radius is 1, in that case simply the length of the arc is equal to the radian. So that means the radian in this case will be how much? 2 pi, because we know that what is the circumference of a circle? There is 2 pi r. Put in this r equal to 1, what we will get? C equal to 2 pi. That means 2 pi is nothing but 360 degree, and when r is equal to 1 unit, in that case, so we have taken this circle of 1 unit, and we have taken one complete rotation, but complete rotation is equal to 360 degree. So we say that 2 pi equal to 360 degree, in this is in radian and this is in degree. So we say that 2 pi radian is same as 360 degree. So this is what we have got, and so let us write down this equation. Therefore we can say that 2 pi radian equal to 360 degree. And now suppose radian is given, that we can convert into degree, and degree we can convert in terms of radian. So it's very simple. Suppose we want the value of say from this we can calculate the value of 1 radian. So this can be written as 2 pi into 1 radian equal to 360 degree. So this will give us 1 radian equal to 360 degree by 2 pi, and this will become, therefore we can say that 1 radian equal to, because 360 degree and this 2 both can be divided by 2, so this will become 180 degree, and what we'll be getting is here 180 degree by pi. So we can say that 1 radian is nothing but 180 degree by pi. And if we solve this one, if we put the value of pi as 22 by 7, and when we get a degree which is suppose we get on division we get less than 1 degree, will come into minutes and seconds, we will be getting this as approximately 57 degrees 16 minutes. But that is what we will not use while doing numerical problems. We will be using this only, that is 1 radian equal to 180 degree by pi. And then if on calculation we are getting a value which is less than 1 degree, we will convert in terms of minutes and seconds. And also we can do the reverse of this, that is suppose 360 degree, from this we can get the value of 1 degree in terms of pi. So 360 degree is nothing but 2 pi radian, and we can rewrite this as 360 into 1 degree equal to 2 pi radian, so equal to 2 pi radian, and therefore what we will get, 1 degree equal to 2 pi by 360 radian. And do not put here degree, because degree will be not coming 2 times. Do not write 360 degree into 1 degree, and this will become just here also we are having this 2 will cancel this 360, and we will be getting here 180, and therefore we will get 1 degree equal to pi by 180 radian. So this is what we will use in our numerical problems. This is the formula which we will use for 1 degree. If you have to convert, suppose degree you have to convert in terms of radians, we will be using this formula. And if you simplify this, that is take pi is 22 by 7, you will be getting 0.01746 radian, that is approximately, but we will be not using this one. We will be using 1 degree equal to pi by 180 only in our numerical problems. Now here we are having some examples. In class 10th we have taken degrees, but we can convert that in terms of pi very easily. Suppose here we already have seen how can we convert degree into radian and radian into degree. So 30 degree we can write as 30 into 1 degree equal to 30 into, now use this formula, we know that we have already derived that 1 degree is equal to pi by 180 radian. So write here pi by 180 radian, and this will give 30 and 180 will cancel each other, and 30 will cancel 180, will be getting here 6, and we will get here pi by 6 radian. So 30 degrees in terms of radian is pi by 6 radian. Now let us take say another example. Say let us take say 90 degree. 90 degree can be written as 90 into 1 degree, and that further can be written as 90 into 1 degree is nothing but pi by 180. So pi by 180 and 90 will cancel 180, so we will be getting here pi by 2. So therefore we can say that 90 degree equal to pi by 2 radians. There is no need to write radians, understood. Even if you do not write, so okay, whenever pi is there, it is understood that we are talking about radians. So but if simply numerical value is there, then you must write radians. If pi is there, then there is no need to write radians. So this pi by 2 radians, when you write, it's very good. Same way you can calculate this others also. Suppose 360 degree. 360 we have already seen that is equal to 2 pi. Nothing in that calculation work. But suppose we need to find the value of 270 degree in terms of radians. So 270 degree we can write as 270 into 1 degree and equal to 270 into, from here 1 degree is equal to pi by 180, and 180 and 270 both can be cancelled out by 90. So on simplification we will be getting 90 to the 180 and 93 the 270. So this will become 3 pi by 2. So therefore we can say that 270 degree equal to 3 pi by 2 radians. So this is how we have got, we can convert degree into radian, radian to degree. So next, now what we'll be doing is that we'll be going exercise 3.1. Question 1, exercise 3.1. Find the radian measure corresponding to the following degree measure. So here we are having degree and we have to convert into radian. So solving question number 1. So let us solve question number 1, first part. Solution 1, first part. 25 degree that we have to convert into radian. So we know that 180 degree, we know we have 180 degree equal to pi radians. So every time we'll be writing this one, therefore we'll be getting 1 degree equal to pi by 180 radian, and therefore we can say that 25 degree equal to, multiplying 25 both sides, will be getting 25 degree equal to pi by 180 into 25. Therefore we can say that 25 degree equal to, and here we can see that both 25 and 180 are divisible by 5. So let us divide them by 5. So we'll be getting here pi, this will become into 5, and when we divide 180 by 5, we'll be getting here 5 3 are 15, so that will become here 30, and uh, 30 will be carried over, so that will become 6. So this is what we'll be getting here. Therefore we can say that 25 degree is equal to 5 pi by 36. Question number 1, second part, exercise 3.1. So second part is minus 47 degree 30 minutes, and we have to convert this in terms of radian measure. So solving this one, we know that 180 degree equal to pi radians. So therefore we can say that 1 degree equal to pi by 180. So we'll take the help of this. Now minus 47 degree 30 minutes, that is equal to minus, we'll take out, and this is 47 degree plus 30 minutes, means that can be written as half degree, because we know that 1 degree is equal to how many minutes? 60 minutes. So if we divide both sides with half, with 2, we will be getting half degree equal to, this will become 30 minutes. So that is what we'll write. This can be written as plus half degree, and this will give us equal to minus this is 94 plus 1, so this will become 95 degree, 95 by 2 degree. Degree will write outside, that means it's common for both. So this is minus 95 by 2 degree, and now we'll use the formula of 1 degree. So this can be written as equal to minus 95 by 2 into, and 1 degree is pi by 180, so pi by 180. Now we'll again divide them by 5. So here this will become, when you divide this by 5, it will here we'll be getting here 1, and 4 carried over 45, so that will be giving us 9, and over 2 into pi, and when we divide 180 by 5, we are getting 36. So this will become minus 19 pi over 72 radians. So this is the answer. This is minus 19 pi. Let me write properly. So minus 19 pi radians. So this is the answer of question number 1, second part. Question number 1, third part. So that is 240 degree. We have to convert into radians. So solving third part. So 240 degree equal to, that can be written as 240 into 1 degree, and we know that 180 degree equal to pi radians. So therefore we can say that 1 degree equal to pi by 180 radians, and therefore this we have 240 degree equal to 240 into 1 degree can be written as pi by 180 radian, pi by 180 radian. Now 0 and 0 will be cancelled out. So, and also we can divide both of them by, so first of all let us divide them by, say, 2. So this will become, therefore 240 degree equal to This can be divided by 2, so it will become 12, and this can be divided by 2, so it will become 9. So what we are getting is equal to 12 pi by 9, and still we can see that both of them can be divided by 3, so we'll be getting 3 3 is 9, 3 4 is 12. So this will give us therefore 240 degree equal to 4 pi by 3 radians. If you want, you can write radians. So this is the answer of question number 1, third part. Fourth part, question number 1, exercise 3.1. So fourth part is 520 degrees. So we'll write as usual. We know that 180 degree equal to pi radians. So therefore 1 degree equal to pi by 180 radians. Therefore we can say that you can multiply both sides by 520. Therefore 520 degree equal to pi by 180 into 520, and this 0 and 0 will cancel out. So, and take care that do not put degree this side, because this all is radian. Now therefore we can say that 520 degree equal to pi. We can divide 52 and 18 both by 2, so this will become 26, and this will become 9, and now we can see that there is nothing common in them, so this will be 26 pi by, so 520 degree can be written as equal to 26 pi by 9 radians. So this is the answer of question number 1. All the parts have been completed with this.